Hello everyone. In today's session, I will explain you a Bezier curves. This is the basically part of computer-aided design. First, let me tell you the little bit background regarding Bezier curves. Bezier curves are the curves methodology which is used to generate a very nice and smooth surfaces. Generally, these curves are very helpful to create a ship hulls, or you can say that propeller of the helicopter, wings of the aeroplane, where we are using a computer fluid dynamics. There these kind of Bezier curves are very helpful. Now here today we are going to discuss one example, or you can say a numerical of Bezier curve. I will explain you a step-by-step procedure for it, but before that I will show you the standard equation which is used for a Bezier curve, which is in front of you on the screen right now. This is the Bezier curve with the 4 control points. So now you might be wondering that what is the meaning of control points. So let me explain you that. Let's say this is one curve which is having a point A and point B here, and now if I want to move this point up, and or you can say down, so there might be a one point. Computer puts one point which is known as a control point in its language, and this control point connects to the both ends. So now moving this control point up and down, I can change the size of this curve which is bounded between this point up and down. So this is the role of control point. So you can understand this kind of control points are total in number of 4. So let's say that the example and the standard equation for it is that if there are 4 control points, then the equation will have also 4 statements. So you can see first, second, third and fourth, and you can see that it is starting into the power of the 3. So if there are 4 control points, so it should start from 3, because there is a 3 minus 0, 3 minus 1, 3 minus 2 and 3 minus 3, right? So 1, 2, 3 and 4, right? P0 is noted as a starting point, P1 is known as a you can say the end point of the curve, where P2 is the another point, control point, and the P3 is also another control point. So there are total 4 control points. So this is the standard equation which we'll use the to solve this numerical. So now let's jump into the example. So today we are going to discuss one example. I'll read out, then we'll explain you what it is meaning of it. Bezier curve is defined by 4 control points. Yeah, we have seen that there are 4 control points. The control points locations are in X, Y and Z: 30, 0, 10, 40, 0, 40, 70, 0, 30, 60, 0, 20. So these are the 4 control points, which are the P0, P1, P2 and P3. So what they are asking, that find the equation of the curve. So final equation for this curve you need to find. And another requirement is the evaluate the function u is equal to 0, 0.2, 0.6, 0.8 and 1. So that can be obtained by the replacing this value of u in the final equation. So we'll see it later. Let's move on. So what are the given data? Given data are P0 is the 30, 0 and 10, P1 is 40, 0, 40, 40, 0, 40, P2 70, 0, 30, 70, 0, 30 and P3 60, 0, 30, right? And notice here that this 30 you can say this 30, 40, 70 and 60 is the x1, x2, x3 and x4. Similarly, this will be y1, y2, y3 and y4, z1, z2, z3 and z4 for us. Okay, now let's move on further. Standard equation which we have written and I have shown you, same equation I am putting it here. Okay, now we will start the calculating this equation for each and every coordinate. So you will get total 3 parametric equation for z, for y and for x. So let's move on for the first for z coordinate. So if it is for the z coordinate, then all the values of p will be replaced by the value of z. So as I said you that this will be a z1 for me, this will be z2, z3 and z4, right? So I'm just putting that equation here: p0z, P1z, P2z and P3z. 1 minus u cube, 1 minus u square, 1 minus u, and here the multiplication with the 3 will be getting powered increased in 1, 3u square. This is the standard equation. You can just understand by rewinding this video. Okay, next what I am doing, I am just replacing and expanding this equation. So if I expand the 1 minus u cube, I will get 1 minus 3u plus 3u square minus 3 simply u cube, and P0z is 10 here. So you can see that P0, so P0z is 10. Similarly 1 minus u square 3u, so it gets expanded 3u, 1 minus 2u, 1 minus u square expansion will be 1 minus 2u u square, right? And P1z is replaced with 40, so you can say P1 and z, which is here, it is replaced with 40. Similarly for this one, 3u square, 1 minus u, 30, right? Now this 30 is replaced from here because it is P3, P2, z, so this is P2 and z, so 30. And the last one is very easy, 20u cube, so 20 is from here, right? So this is the final one. Okay, I will just update it for you that this is not a 30, this will be a 20 for us right now, so I'm putting it as a 20. Okay, so 20u cube. So finally if I put those values here, so simplification I will get in this manner. You can do it is very easily, and this will be the last equation, which will be the multiplication of u cube, u square, u and 10. So this is the equation which is required to us right now for the z. Similarly if we found for z, we should found for the x also, right? So for x coordinate the same thing I am doing. See, this equation is same here, 1 minus u cube, simply I am just replacing z with the x. So previously we were putting these values, now we are replacing these values, 30, 40, 70 and 60. So now you can see it here, right? These values are replaced, 30, 40, 70 and 60, right? So these all values are replaced here, and simplifying this equation I will get this answer as an answer, 60u cube, 60u square, 30u and plus 30. So this equation will be a equation for x for us, right? So now we found the x and we found the z. So what about the y? Similarly you can find the y also, but if you notice here that the all values of the y are 0, right? 0. So if you put those value as a 0, then this equation will become automatically a 0, so you don't need to calculate it. So we are considering that Puy is equal to 0, so its equation will be the 0 for us, right? So this was the first requirement. So what they were asking, that find the equation of the curve. So these are the equation of the curve, right? This is for z and this is for x, and if y is there, then there will be a y. But simply you need to remember only, just memorize this equation and it will solve your all problems. Okay, so this was the half part of numerical. In second part they are asking, evaluate the function u is equal to 0, 0.2, 0.6, 0.8 and 1. It is very simple step. See, what I am doing here. See, u is equal to 0, 0.2, 0.6, 0.8 and 1. So you need to prepare a table. You will put 0 as a column, 0.2, 0.6, 0.8 and 1. And now what you need to do, you need to write a px, py and pz. Now this px represents the standard equation of x, which is here 60u cube, 60u square, 30u and 30, right? Py we all know 0, and pz, so there is also standard equation we got, 40u cube, 120u square, 90u plus 10. So now what you have to do, you have to replace the value of u in this respective equations. So for this pxu, I will replace u is equal to 0. So if I replace u is equal to 0, here 0 and here 0, here is not a u, so it will not be a 0, right? So this term will be a 0 for me, this term will be a 0, this will be 0, left what? 30. So I am writing a 30. Similarly 0.2, so I am replacing 0.2 here, here, here and here. In px equation I have to replace these values respectively, and I am getting this simplification, and so on you need to carry on. For py, it is 0 already, so all values will be the 0 because there is no u, then you cannot calculate it, right? And in pz, I have to replace this 0 where the previous equation for pz which I have got, the final equation, it should be in u cube, u square, u and 0. So I'll replace 0, 0, 0 and here. So the first point should be a 10. Why? Because replacing a 0 will make this terms as a 0, right? So for further 0 0.2, 0 0.6, 0 0.8 and 10. So by replacing these values, you can get this answers respect to the pz. This is respect to the px, right? So this was the second part which was asked to the this numerical. So this is all about the Bezier curves equation and numerical. Just to revise, I would like to make you remember that if 4 control points, then this will be the equation. There might be a cases of that they will ask 3 control point or 2 control points. So you need to deduct this power value and just reduce this equation, and you will get the 3 control point answers also. So that's all for the today's session. In next session we will cover something new. Till that, goodbye.